Hi, welcome to Smooth On's Concrete U. My name's Adam.
And I'm Kevin.
And today we're going to talk about some of the basics of GFRC. We've done a number of videos showing the process of GFRC, but we've never really gotten into the actual components or a little bit more about the mix design. So we wanted to produce something that gave a little bit more detail about those aspects of GFRC. We're going to have kind of a conversation about the materials themselves and then talk a little bit about two different types of mix design and then like a sequence of mix design. So let's just start by defining what is GFRC. GFRC stands for glass fiber reinforced concrete, and that's what it's known as in the United States, but the rest of the world it's called GRC.
I like GRC better.
It's a little shorter, but it just kind of happens to be how the names evolved over time. So what it is basically is a Portland cement sand slurry mixed with glass fiber, which has very high tensile strengths and impact resistance. And overall, it's a very versatile casting system. It can be used for a lot of different types of applications, from big architectural pieces to small ornamental things. Very versatile in the color, very versatile in the different finishes you can achieve.
As Adam mentioned, we do have a lot of videos on how GFRC is used, many different applications of it. And feel free to check those out on our Concrete U YouTube page, and as well as our website.
Okay, well, let's get started with some of the materials. Let's start with the basic building block of all concrete systems and of GFRC systems, and that is Portland cement. And this is Portland Type 1 cement, and you'll see it's both available in white and in gray. But there's some differences though, right, between the white and the gray in terms of their use?
Yeah, although they are both Type 1 Portland cements, there are some advantages to using one or the other. The white is going to be more expensive and a little bit more difficult to find. However, white is the best material to use for coloring pigments, so you don't have to overcome the dark gray tint that's already there.
Right, and white tends to be a little bit more consistent overall in terms of the color finish, right?
Absolutely.
Yeah, we can find these at Mason Supplies. Most of them should carry Portland cement, Type 1 cement. The common producers for the white are Federal and Lehigh. They make a lot of cements and very widely available throughout the United States anyway. This basically is the binder that holds all the components together in a GFRC mix or in a concrete mix is cement. In a GFRC mix, we're approaching a very low water to cement ratio. So high quality cement is important, and these two are Portland cement Type 1 is generally the best option.
And a key in GFRC is having fresh Portland cement. As you can see here, that we have a nice fine powder that's free of clumps. And
clumpiness could also clog up your machinery if you're using a spray gun and things like that. So it's important to...
We've had some bad experiences.
Yeah, that happens from time to time. So fresh materials, that's definitely a key. The next largest component by volume, by weight, is going to be silica sand. A very specific type of sand though, right?
Yeah, as with many concrete applications, sand is always involved. Typically you can use a wide variety of sand and depending on what's locally available. What makes it a little bit more interesting with GFRC is that it needs to be spec'd. We recommend 30 mesh silica sand, meaning that there's zero retention on a 20 mesh sieve. So that means that there's no large particles that could clog up a gun or even a mixer or pumping equipment depending on your application.
Yeah, so you can't just use basic playground sand.
Correct.
The size of the component is very specific. So larger pieces of sand or aggregate, as you say, could clog up your machinery, but also the fines, the small particles, can also cause problems. And that you usually see in they're drawing water away from the rest of the system. Going back again to the low water to cement ratio, we're going to keep hitting on that low water to cement ratio in this blend. It's important to have this sand also be washed, free of contaminants as well, and dry in general. Again, water cement ratio. Some sands can actually hold up to 5% water or even more potentially. So that's going to really throw off your ratios when you're getting into a very specific mix design like you do with GFRC. So this isn't very easy to find, would you say?
Typically you can find any type of sand in a masonry supply, but this type of specified sand can be difficult to find. So it's best to contact your local masonry supply, but if not, search the web for your local silica distributor or supplier, and they could point
you should be able to find
direction.
somebody and pick up bags of this as well.
Mm-hmm.
So, okay, well, let's move on to the next dry component of the GF in GFRC. This is glass fiber, and it's not just any type of glass fiber, is it, Kevin?
No, this is AR glass fiber, and that's important. The AR designates alkali resistance, and Adam had mentioned alkali resistance is important because in normal Portland cement, the very high alkalinity will break down normal glass. Anyone that's familiar with glass fiber is probably familiar with something that's called e-glass, and it's used in a number of different
boating
industries.
or composite applications. So if you look through our website, you'll see composite applications very regularly, and they'll use all sorts of e-glass. And e-glass is not alkali resistant in the way that AR glass is, so it is not suitable for GFRC applications.
What will happen is, over time, it may initially being mixed, it will look just the same, but over time it will break down and all that strength you're counting on in that glass will fail, ultimately causing the entire matrix to fail.
And not only is it a spec as AR, but there's actually a minimum content of zirconia that's required for suitability in GFRC, and that's 16% zirconia. That's, again, another thing that should be spec'd out. There's a few major suppliers of AR glass, and they're all up to that spec. So if you follow that rule, then you should find the right product for it. It is available in different formats, different packaging sizes. This is a chopped strand, so literally chopped up pieces of glass fiber, available most commonly probably in 1/2 inch or 3/4 inch sizes, but it is smaller and larger as well. It's also available as kind of like a big ball of twine, which is called roving. And the roving is used on some higher end machinery where actually it's not premixed into the slurry, it's chopped while the spray is coming through. So that's a different type of AR glass. A third type would be scrim. Scrim is a grid-like pattern of that continuous roving, and it's sold on a roll, and that's used for added reinforcement or specialty reinforcement. We saw that in a project going to Miami, right?
Yeah, the scrim was actually specified by the architect to meet the local Miami-Dade building codes for hurricane resistance. So again, when speccing all these types of materials, be sure that they comply with what is recommended for the mix design, but also your specific project.
Yeah, those were for some panels. We had a video on these kind of angular GFRC panels that went onto this really cool building in Miami. So we'll move on to some of the wet components now, right? Let's take a look at this one. This will probably be our shortest explanation. This is water, and it's just potable water. And the key to this is basically that it's free of contaminants like iron and salt, and generally just a clean source of water.
Yeah. Unbelievably though, we've had problems, customers reported with having heavy metals in their water supply that causing issues long-term with color and other things like that. So just make sure you can see through it.
I guess that's it. But you might have to have it tested if you're having any kind of issues like that. So the next component is the second liquid component. This is maybe the key to the whole system, and this is an acrylic copolymer dispersion called Forton VF-774. It is a 51% solids ratio, and it's really added for two main reasons. The first is that it eliminates the need for a 7-day wet cure. I know you have a construction background. Can you explain a little bit about what the 7-day wet cure means and why this product helps eliminate that?
Sure. So typically with concrete applications and architectural pieces, 7-day wet cure was required to maintain or to build that initial strength. Most of your strength that you get from the Portland hydration comes within that first 7 days. So it was important to keep all those pieces wet and have the moisture available so that cement hydration could happen. Would happen if there was no polymer in it or they weren't being continuously wet. The moisture would evaporate or dry off before the cement had the opportunity to hydrate. So what this does is film form, trapping the moisture inside and eliminating that 7-day wet cure. And that's important for producers because now they have, instead of having their entire shop filled with sprayers and water and these soaking wet pieces of concrete, right, now they can demold them, put them outside or post-finishing them a lot faster and quicker turnaround.
Right, the speed, that's really important.
Yep.
The other main benefit has to do with kind of long-term durability. The polymer itself, and this has been shown through over 20 years of independent test studies, has great properties for maintaining the flexural strain to failure property. And what that means basically is it maintains the tensile strength and impact resistance over time for that GFRC matrix. And it's kind of a technical read, but you can go through the articles and tests that are published on our website for some more information on that.
And that's very important. You know, we talk about a lot of these technical terms sometimes, and if you're making a countertop that's going to go in your backyard, it's important. But if this architectural cladding piece is 60 stories up in a downtown environment, that is very important that these don't break, crack, or fall off, and could really cause some damage.
Yeah. So like you said, though, it's important for these large pieces, but you still don't want your backyard countertop to crack in half in a couple of years either. So
absolutely.
So again, another benefit of the Forton. Now there are some ancillary benefits, some added benefits to adding the Forton that may not be as high a priority as those two. One of them is a plasticizing effect, and that's again coming back to this low water cement ratio. And we're going to talk a little bit more about plasticizers, but in general, it will help the workability of the material without having to add extra water to the mix. Another one is improved color performance, and if you're pigmenting the material. So color evenly disperses in the Forton, and ultimately evenly disperses in the GFRC matrix because of that. It's UV stable on top of that, so it won't yellow over time.
Yeah, what's interesting about color and difficulty with color, and that maybe not be true of other polymers, is that the polymer size in the Forton VF-774 is very uniform and is spec'd in the technical bulletin, but also when they're producing it. That means a lot when you're going with color consistency. If you have different size particle sizes within the polymer, that will reflect differently once the piece is cast.
Right.
So having uniform batch to batch, but also within just the actual liquid itself, really helps maintain that color uniformity.
Yeah. And that's a big selling point of this material, is the tight tolerances that it's produced to, and that's very important for large industry producers that are certified by the PCI for making architectural panels. But that benefit rings true for everybody, even down to the small and medium-sized users that we deal with every day.
Yep.
There's some other added benefits too, right? Like moisture absorption.
Yeah, moisture absorption is something that most people don't think about, but when you're really going for the freeze-thaw cycles or even efflorescence, it comes down to how the water gets into the concrete to begin with. With the polymer in there, it seals all the porosity and makes the overall water absorption less. Therefore, you get increased freeze-thaw cycles, as well as the efflorescence or salt migration through concrete, causing the white milky powder substance on the outside of the concrete. It really cuts down on a lot of that.
Right. The other added benefit that you see a lot is a reduction in the spider cracking or craze cracking that can come about if you don't use any polymer. You'll see this at the surface of the part. As the concrete cures and shrinks a little bit, there can be some cracking. But with the soft polymer particles like this between the sand and cement particles, it helps reduce that spider cracking. So another kind of important factor there. We offer this product in pails and drums and totes. So again, used for all levels, all sizes, very important benefit for GFRC producers.
And there's also a lot more information, like Adam had said, on our website about the product, why use Forton VF-774, as well as 20-year durability studies.
There's also some comparative data comparing it to other types of polymers out there. So interesting reads, some technical information, but you can always call us with additional questions. Let's move on to another liquid component, and this is added in a small percentage, but has a pretty big bang for your buck, right, Kevin?
Oh yeah. Plasticizers are what really allows us to have the low water to cement ratio. Here we use a super plasticizer, otherwise known as a high range water reducer. What this does is allow you to attain that high workability to be able to spray concrete or to apply it by hand without affecting the low water to cement ratio that are common or essential in GFRC.
Again, not a whole lot is added to a system though. You might be looking at between like 4 and 8 fluid ounces per 100 pounds of cement. So it's really not a lot, but it's very key when you're getting into the workability of the material and the sprayability of the material, for it to be able to move through a gun but still hold a vertical surface when you apply it onto your mold. So this is a pretty key component. We recommend some products from ADVA. The ADVA 140, ADVA 190 are good materials, and there's some others on the market as well.
And that's important too, to also consider what type of plasticizer you're using. You had mentioned the ADVA 140, which is this, and it's great for spray applications. Will hold the vertical surface but still provide that workability. But there's also SCC plasticizers, which are also recommended in our technical bulletins, which is better for backer mixes or something where an application where it's not going to be sprayed or held a vertical surface.
Right, so self-consolidating concrete, SCCC, right. All right, so I think that's plasticizer. We can move on to pigment, which is available in different forms. This is an iron oxide pigment. This is kind of a golden brown color, but it's available in a wide range of colors from a wide range of manufacturers. This is added as a percentage, and again, it's kind of key to, you would add it to the white cement, and it's key to coloring, obviously, any cement that you wanted to actually pigment to a particular effect. Now, there are other colorants. This is an intrinsic color, but there's also extrinsic color or topical colors that would be put on afterwards. So the iron oxide and there's other liquid pigments are added intrinsically. So now that we've kind of covered some of the components, let's talk a little bit about mixed design. And mixed design, what that means is the specific ratio that the components are mixed at. And if you review our technical bulletin, you'll actually see two different mix designs on there, right, Kevin?
Yeah, and it causes a little bit of confusion, quite honestly, and especially when we first read it. We see a pre-mix as well as a spray-up different mix design. They're a little bit different in their formulations. But why don't we talk about the difference between spray-up and pre-mix and clarify some of the questions that some people might have.
Sure. Well, let's start with spray up, which would probably be less typical for the majority of users. Spray up application is used by high-end producers, generally speaking, and this is when you have large volume spray equipment and you're actually not mixing in the fiberglass into the cement slurry. You're going to use a gun that actually chops the fiberglass separately and sprays the cement at the same time. So that kind of high-range equipment, that type of process we showed from those two videos from GFRC Cladding down in Texas, and to make those very large architectural panels. So that's pretty common from there. But more common for the small, medium, and even some larger users is the premix mix design and premix process. So tell us a little bit about that.
The premix, like you said, is a very common mix design that a lot of people use. The misconception is that it can still be sprayed, and that's where we have the confusion of spray up and premix.
Right.
The premix is sprayed through a hopper gun, generally on a smaller application, and then the backer mix is applied generally by hand.
So the face coat, in almost all circumstances, is going to be sprayed. That's the best way to do it. So that's where the confusion. If it's sprayed no matter what for a face coat, you might think, well, I should go with the spray up mix design, but actually, if you're using a hopper gun and then mixing the fiber in for the backup mix, that you probably want to go with the pre-mix.
So yeah, now that we're talking about the backer mix, with the spray up, you get a higher glass percentage. And if you look on our technical bulletin, the spray up mix design ultimately has higher flexural strengths and a number of other higher physical properties. That's because with that system, you can get up to 5% glass loading in the entire mix.
Yeah, very difficult to mix that much glass, pre-mix that much glass, and get good placement of it ultimately when you're doing a pre-mix application. Right? Yep,
but still a great mix design nonetheless.
Yeah, absolutely. Well, that's kind of to define the different mix designs, but let's talk about the process of how the material is mixed. So that's also very important, right? The sequence of events on how the material is mixed. Again, this is on the technical bulletin, but I think it requires a little bit of additional explanation as to the why of why we're recommending it this way.
Yeah, so following basic mixing principles of a lot of different materials, we always want to add the dries to the wets. That ensures that the material gets mixed evenly, it cuts down on clumping, but also a number of other problems by starting off with that.
So you start with your water and your polymer and you blend those together first, right?
Yep.
So those get thoroughly blended. You might add a little bit of plasticizer for workability at this point. And if you're coloring the concrete, coloring the GFRC, you'd also actually add that color at this point as well, right?
Yeah, that's the only caveat. Whether you're adding a liquid or a dry pigment, that's the time to do it before any of the other sand or cement or dry components are added.
It helps achieve the uniform color throughout the whole system, right?
Mm-hmm.
The next component that you would want to add is the sand, actually, and that's for a good reason, right?
Yeah, by adding the sand first, it helps keep the cement from clumping in when that's added. If the cement was added first, it would have the tendency to clump together and not mix thoroughly, resulting in dry clumps, and that would clog up your sprayer gun, but also could provide an uneven surface when you ultimately cast the piece.
Right, so those kind of sharp, loose sand particles through the high shear mixing will actually break up the cement that is being distributed into the mixing vessel. Okay, well that's important. Then you're adding your cement. adding that and thoroughly blending everything together, at that point you basically have your face coat mix done. That's as far as you need to go for a face coat mix, right? Mm-hmm. So that's ready to be poured into a hopper gun and sprayed, or if it's a large application, gone through a larger spray equipment as well for face coat. Now the backup mix is identical, right? That's the same exact components for the face coat as the backer mix, right?
Yeah, having the same mix design is very important. If the mix design is different, it could cause delamination in the ultimate piece between the face coat and the backer mix, which could be catastrophic.
So the only difference between the face coat and the backup mix is the addition of the glass fiber.
Correct.
So you pre-mix everything else first, right? And then you throw the glass fiber in. But that's important to keep track of how fast the mixer is going and how long you're blending that fiber in for, though, right?
Yeah, and we'll ultimately get into in another video regarding machinery and mixers about different speeds on mixing and those types of things. But the important thing is not to over mix it, because if the glass fiber gets over mixed, you break down the fiber, it could filamentize and bird's nest, causing workability and placement problems, but more dangerously, failure of the glass over long term.
Yeah, strength issues over time,
Yeah.
right? So that's, after that's all mixed together, you're ready for placement, whether it's done through a gun or by hand, which is most typical and what you probably would have seen through most of our videos. Well, that's kind of the basics of the components and the mix for GFRC. We're going to have more videos in the future, but I encourage you to check out our website. We have a very extensive FAQ section. Our technical bulletin has a lot of good information on it. And again, a lot of good reading material. You're always welcome to contact us for specific questions or projects that you have coming up, but definitely check out the website. Again, I want to thank Kevin for having this conversation with me, and we'll see you next time on Concrete U.
Thank you.